Good morning and welcome to our senior project presentation. Our presentation will be on scheduling solutions for advising services. We worked with the Bronco Advising Center, also known as the BAC. Our team consists of Lauren Grudgeon, Brian Rosales Almanacid, Joshua Sisip, and myself, Laura Mejia. We will be going over our project description, the objective, the structure of the Bronco Advising Center, the current state of the BAC, schedule allocation through optimization, and with that, we will show alternative solutions to the schedule. With the alternatives, we will find significance with hypothesis testing. We will then discuss the cost analysis and be wrapping everything up with our conclusion and lastly, acknowledgements. The Bronco Advising Center is a one-stop centralized advising facility that focuses on providing advising to students who may have questions on topics such as academic records, class registration, financial aid, etc. Our focus is to meet student demand with a limited number of advisors, determine staffing levels with alternative schedules, and new techniques of online advising that were implemented during the pandemic. We hope the impact of our project will ensure effective planning to better student experience, find the minimum number of staffing required, increase timely responses to student inquiries, and increase accessibility of advisors due to virtual practices. The objective of our project is to investigate various methods of optimizing staffing schedules to better serve students by reducing unique schedules by 50%, and reduce both time in system and wait time in queue by 5%. Now Lauren will be going over the structure of the Bronco Advising Center.
The Bronco Advising Center consists of 5 different employee categories, being advising staff, advisors, staff, undeclared advising staff, and student assistants. The BAC receives general advising questions from students through 6 different forms of communication: calling, scheduled online appointments, Ask Billy through the Billy chat, walk-ins, email, and social media messaging. Some assumptions our team worked with regarding gathering data from the BAC was that we would only use data after the pandemic started, so data from April to October 2020, with students and faculty fully online. We also only considered 2 forms of communication, phone calls and online appointments out of the 6 mentioned earlier due to data and pandemic limitations, since not all of the data was captured, making those other forms of communication inaccurate to work with. And lastly, we only use data from the BAC's full-time employees. The time advisors spend with students on a daily basis can be broken down into 80% of their time working with students and the other 20% of their time working on other projects. That 80% can be broken down again into 60% working directly with students, being in a one-on-one meeting with them or answering back an email, and the last 20% is note-taking either before or after said meeting. For our current state of the Bronco Advising Center, our team developed a simulation from gathered arrival rates based on the incoming phone call frequency and scheduled appointments. We also took into account the different service rates based on the probability of students asking different types of questions. The service times also vary depending on which individual advisor the student speaks with during their meeting. This is due to the hierarchy of different backgrounds and experience levels of advisors. As seen in the simulation model, the current state is comprised of 11 employees working Monday through Friday for about 40 hours each per week. The hierarchy of the different backgrounds consists of 3 BAC advising staff, 4 BAC advisors, 2 BAC staff members, and 2 undeclared advising staff. Each advisor has their own unique schedule, including break times. They have a higher priority to finish their meeting with a student than going on break or leaving at the end of the day. Next, Joshua will talk about the optimization based on the current state's results.
In order to figure out what combination of schedules and staffing levels are needed to minimize average overstaffing, a linear programming model was formulated. The model uses parameters which are given pieces of information as inputs to the model. The parameters used were T, which is a time period when an employee can be scheduled, For this model, we are breaking an 8-hour day into 21 30-minute intervals. PIT is a binary parameter that has a value of 1 if it is within schedule I and a time period T for an employee to be scheduled. LT represents the minimum number of employees needed at time period T. For example, we need a minimum of 2 employees working at 8 a.m. N is the number of time periods, which is 21 30-minute intervals, and we are analyzing 11 different schedules. The decision variable is xi, which represents how many people are scheduled for I schedule. The formulation can be read as minimizing the average over staffing, which is a summation of all employees scheduled at a specific time period minus the minimum number of employees needed at that time period, divided by the number of time periods analyzed. The model only has one general constraint, which is to ensure that the BAC is sufficiently staffed at all time periods. On this slide is the formulation implemented into Excel Solver. This is PIT. The leftmost column represents the I schedules, while the top row represents the time periods T. The way to interpret this table is that if there is a 0, that means an employee is not scheduled to work on that corresponding time period for that schedule. This is the output of the model. To minimize average overstaffing, the BAC should schedule 2 people to BA1 schedule, 5 people to BA2, and 3 people to BA4. This is calculated by taking the sum product of the time period column with the employees needed column to obtain people scheduled. The minimum number of workers is determined by finding the number of employees to reach 70% utilization. Then the model subtracts the number of workers scheduled with the minimum number needed to obtain the overstaffing. Then the model takes the average of all the overstaffing values to reach its final value, which is 3 people overstaffed on average. From the model outputs, the team was able to develop 2 alternatives. Alternative 1 is using just the optimal schedules without changing staffing levels, while alternative 2 is changing both the schedules and adding more employees to the simulation. The 4 metrics used to judge the system are work in progress, time in system, wait time in queue, and number of students served. Alternative 2 slightly decreases the average WIP and time in system. It significantly decreases the average wait time in queue and slightly increases the average number of students served over the baseline. When compared to alternative 1, there are significant differences in WIP, time in system, and the number of students advised. I'll be passing it on to Brian to talk more about system comparison.
Once we obtained the results from our alternatives, we decided to compare them statistically by using hypothesis testing. Since we were interested in the difference between the performance of the current model and our proposed models, we chose the pair t-test to compare these results. mu1 represents the average of the metrics we obtained from our current system, and mu2 corresponds to the alternative results. For variables such as working process, time that the student spends in the system, and waiting time student spends in the queues, having a lower average means that the service provided by the BAC is better. So we decided to test whether the proposed alternatives have a lower population average than the current model, which makes this a right-tail test. On the other hand, the number of students advising our proposed alternatives should be higher than the results from our current model. To see whether or not this was the case, we used the left-tail test shown on the right. Since our alternative hypotheses are the ones that display our desired results, rejecting the null hypothesis would mean that our alternatives are better than the current model. To keep the results consistent, we use a significance level of 0.05 for all the tests. Based on the 4 metrics analyzed, we summarize the results in these tables that show the p-values obtained for each one of the tests. These values are to be read from row to column. For instance, in the first table, which shows the results corresponding to work in process, alternative 2 has improved significantly compared to alternative 1 if the significance level chosen is greater than 0.03. The most impactful results are shown in yellow since they indicate the instances in which our alternatives are notably better than our current model using a significance level not greater than 0.05. From these results, we can conclude that the second alternative we proposed is the one that would benefit students the most. With this in mind, our cost analysis focused on evaluating the effect that implementing our proposed model would have on students who do not finish their degrees. Based on our research literature, we found that only 61% of students who are pursuing an undergraduate degree completed within 8 years. Then we found the most current data of students who started their undergraduate educations in the school year 2020 to 2021. We determined that retaining a percentage of students who are at risk of dropping out by increasing the overall reach of advising services would in fact provide us with a net present value of approximately $12 million in the following 8 years. More importantly, this increased capacity of advising services can be accomplished by implementing our proposed alternative. Using this new model, we decrease the variability of schedules by over 70%, and we reduce the time a student spends waiting in line and the overall time a student spends in the system by 12% and 1% respectively. These results are critical for us since the BAC advisors would now be less overwhelmed by the increasing student demand that was projected to become more complicated to handle. Finally, our recommendations for the BAC are to increase their staffing levels, implement a newly optimized set of advisor schedules, and improve their current data logging system so that any future project to further improve their services can be done more efficiently.
First and foremost, we would like to thank our senior advisor, Dr. Mirzai, for all her guidance, patience, and knowledge she was able to share with us. We would also like to thank the Bronco Advising Center, especially Zoe Lance, Jay Ibu, and Dr. Cecilia Santiago Gonzalez for allowing us into their department and making possible improvements. We'd like to give a special thanks to Dr. Ghosh for taking the time on his off semester for his assistance. And lastly, the Cal Poly Pomona's Industrial and Manufacturing Department for keeping us motivated for more than 4 years.
Thank you so much for your time and attention. Any questions?